So in this video, we're going to talk about how to select an appropriate model to represent some data. So in the work we're going to be doing today, we're going to need to view some scatter plots on our calculator. So we're going to need to make sure that that feature is turned on. So to turn it on, you're going to click second and then choose stat plot, which is right above the y equals sign. So we click y equals and then hit enter on plot 1. So you can see right now it's turned off. So I'm going to click enter on so that that feature is turned on. And now if I have values, so like you can see in stat edit, I have some numbers entered into L1 and L2. If I go to zoom now and I scroll down or I click on number 9, okay, which is zoom stat, it will create a scatter plot with that value, all the values that I have listed in L1 and L2. Okay, so we're going to need that today. Another thing we can do is when we have our regression equation figured out by the calculator, it will graph it for us over the scatter plot so we can see if it's a good fit. So for example, this data here, I'm going to model with a linear function. Okay, so I'm going to choose 4. When I'm on this calculate screen where it says store regression equation, okay, I'm going to click alpha and then trace. You can see right now it gives me y variables, so I'm going to choose y1. And what that's going to do is it's going to store that regression equation in y1. And so now when I hit calculate, you can see my equation is y equals 2x plus 2. If I click on zoom 9, what it does now is it'll graph that line along with my scatter plot so I can see whether it's a good fit for my data. Okay, so another way to figure out whether you need a linear, quadratic, or exponential model is to look at the table of values. So here in blue, I have a linear function. Okay, so notice that every time my y values are going up by 2. Okay, remember that is a characteristic of a linear function is you have that constant rate of change. Now let's look at my quadratic. Well, the first time it goes down 1, right? Then it goes up by 1. Then I have up 3, and then I have up 5. Okay, so it's not a constant rate of change. But if we look at the rate of change of the change, you can see there's a constant value, right? So here it goes up 2, here that's plus 2, and then here that's plus 2. Okay, so that is a value called the second difference. Okay, in a quadratic, the second difference is always going to be the same. If we have an exponential function, okay, notice it's going to be multiplied by the same amount every time. So for example, if I do 1.5 divided by 0.75, okay, if I take the two numbers and divide them, I get 2. So this is going to be multiplied by 2. Same here, okay, if I do 3 divided by 1.5, that equals 2. So in an exponential function, you're actually multiplying by the same amount every time. Okay, so what this is called is when you have a linear, you add or subtract the same number every time, so you have a constant rate of change. In a quadratic, the second differences are the same, and in exponential, you have what's called a common ratio because you're multiplying by the same number every time. So what we're going to do is we're going to look at different types of data and determine whether we can model it with a linear, quadratic, or exponential function. Okay, so I'm going to clear what I have here. I'm going to go to stat edit. Okay, I'm going to clear L1 and L2, and what I'm going to do is input this new data that I have. So for my X values, I have 1, 2, 3, 4, and 5. And then in L2, I'm going to enter my 5.1, 7.2, 9.1, 10.9, and 12.8. Okay. So now I want to look at the scatter plot, okay, to just get a visual and kind of predict what function I think would be best to model this. So it looks pretty good like a line, right? I think it looks pretty close to a linear function, so I'm going to try using a linear model to represent this data. So I'm going to go to stat and then arrow to calculate, and I'm going to choose option 4, which is linear regression. So I'm going to hit enter, and then on the store regression equation, I'm going to tell it to store it in y1, right? So you click alpha, trace, and then enter on y1, and then calculate. Okay, so from the R value right here, that R value is very, very close to 1, so I think it's a pretty good model. I can confirm this by clicking zoom and then going to 9, and you can see that this linear function very, very nicely models this data set. Okay, so that's going to be a good equation for this information here. Okay, so what about this data set? So I have a whole new set of data here, so let me clear everything that I have. I'm going to go back to stat edit. Okay, I'm going to clear L1 and L2. And I'm going to input my new data values. Okay, so in L1, I'm going to do 1, 2, 3, 4, 5. And then in L2, I'm going to do 4, 5, 6.24, 7.7, and 9.75. Okay, so now when I click on Zoom 9, here is my scatter plot. So it doesn't look like a line, right? I kind of have this curved shape. So I'm thinking quadratic or exponential, okay? Linear doesn't look good. So how do I figure out if it's quadratic or exponential? Well, for quadratic, right, I'm going to look at the difference. So here it's going -1. Here I have plus 1.24. Okay, from 7.7 to 6.24, let me see. Let me figure that on my calculator. So I have 7.7 minus 6.24, and that gives me 1.46. And then from 9.75 to 7.7, let's see, I have, whoops, 9.75 minus 7.7. That gives me a difference of 2.05. Okay, so remember for quadratic, I want to look at the difference of the difference and see if that number is constant. So 1.24 minus 1, that is going to be 2.24. Okay, so that difference there is 2.24. If I do 1.46 minus 1.24, that is going to be 0.2. So already it's not looking like my second difference is the same, right? It's too different for it to be a quadratic. If I do 2.05 minus 1.46, that's going to give me 0.59. Whoops. 0.59, so that does not, I'm thinking it's not quadratic, okay? How do I check if it's exponential? I want to look if the common ratio is the same, okay? So if I do 5 over 4, if I do that on my calculator, 5 divided by 4 is going to be 1.25, okay? And then if I do 6.24 divided by 5, okay, I want this number to be like the same or as close to same as possible. That's 1.248, okay? Kind of looking like it's going to be the same ratio every time. If I do 7.7 divided by 6.24, we have, let's see, 1.23. And then we have 9.75 divided by 7.7. 7.7. And that is 1.26. So it looks like the common ratio is about the same. So I'm thinking maybe exponential, okay? But we always want to double check and make sure that our prediction is correct. So we're going to go to Stat Calculate, right? And we're going to choose Exponential Regression, which is option 0. Hit Enter. And then in Store Regression Equation, we're going to tell it to store in Y1. So click Zoom Trace and then Enter. Whoops. Alpha Trace. Hit enter on Y1, hit enter again on calculate, and it gives you the calculation, right? So look at the R value. It's very close to 1, so that's already telling me it's a pretty good model. But just to make sure, let's go to the graph. And you can see that this exponential model very, very nicely passes through almost all of the data points. Okay, so that is going to be a good model. So this is exponential. Okay, so now let's try this one. Let's go ahead and let's clear y equals, and let's go to Stat Edit, clear what's in our table, and enter these new values. Okay, so in L1, I'm going to enter 1, 2, 3, 4, and 5. And then in L2, I'm going to enter 4.1, 5.2, 7.9, 12.8, and 20.2. Okay. So if I go to Zoom 9, here's my graph. It definitely does not look linear, okay? So I'm thinking quadratic or exponential. So to figure out if it's quadratic, I'm going to look at the differences, right? So I do 5.2 minus 4.1, and so that is a difference of 1.1. Then I do 7.9 minus 5.2. And that is a difference of 2.7. Then I do 12.8 minus 7.9. And that is a difference of 4.9. And then I do 20.2 minus 12.8. And that is a difference, whoops, I did plus 20.2 minus 12.8, and that is a difference of 7.4. Okay, so now I look at the difference of the differences. So I do 2.7 minus 1.1, and that is 1.6. 4.9 minus 2.7, that is okay, and then we have 7.4 minus 4.9. And that is about 2.5. So I know these common differences, the second differences are not exactly the same, but they're all pretty close to 2. So I'm thinking quadratic might be a pretty good model here. So let's go ahead and try that. So let's do stat arrow to calculate, and then we're going to choose option 5 for our quadratic regression. Okay, so hit enter, keep hitting enter, and then here we're going to click alpha trace, and hit enter on y1, and hit enter again, and it's going to calculate our function for us. Okay, so we can go ahead and go back to our Zoom 9, and you can see that this quadratic model does in fact very nicely fit our data points. Okay, so that is how you can look at the scatter plot and study the values in a table to determine whether a linear, quadratic, or exponential function will best model a data set.